Welcome to meteorology. Just want to start just giving you a quick little summary of some things here. Uh, we're going to be learning a lot about the weather over the next semester. We're going to start looking basically at the variables that make up the weather. Things like when you walk outside, what do you want to know about? You want to know about temperature, maybe the wind, maybe how humid it is, how many clouds are in the sky, is it going to rain? Each one of those is kind of a variable. So we're going to start just learning about them first. And we're going to look at observing the weather right now. That's where we're going to begin. Just you can't make a weather forecast or understand the weather unless you know what's going on currently. So I started out just pulling up a weather map. In this weather map, we have warm fronts. Warm fronts have like a half a moon, semicircle on them, indicating the direction of motion. They're pointing that way. So this warm front is moving to the north. Here, let's start with this one. In the central Midwest, you can see a cold front. They have triangles on the ends. And the direction that the triangle is pointing is the direction the front's moving. So this front is moving to the east. Now, we have low pressures and high pressures. Pressure is a variable we're going to learn about. But right now, it is going to say, oh, high pressure here. Generally, high pressure brings good weather. If you're in the eastern United States right now, we have pretty good weather. Generally, sunny skies. Now, however, you look out here in Kansas and just south in that area, we have low pressure. So this is just giving you a state of what the atmosphere is at this moment in time. And the latest one of these is right here. Much later, things have changed. You'll notice that the other one was 21 hours ago. So if I had used that as my current observation, I'd be way off of what's going to happen in the weather. Notice the low that was down there now has been replaced by high pressure. High pressure that was over us is now off of the East Coast. We have a warm front all around us here, coming up through West Virginia, Ohio, Pennsylvania, even. And we have warm air coming in off the ocean, warm air coming up from the Gulf of Mexico, cold air coming down from Canada. So it just gives you an idea that we want to know observations at this moment, instant in time, in order to tell what the weather is going to do in the future. So let's take a look now at observing the weather. One of the ways we observe the weather is we look at satellite images. And this is a satellite image that's currently happening right now of the continental United States. Notice there's clouds coming up here. That would be along that cold front we were looking at. You'll also notice there's red and yellow and green dots here and changing different configurations of color. What they are is lightning. We can detect with satellites where lightning is occurring. So we are actually observing the lightning and thunderstorms down over this area right now in conjunction with the cloud cover there. If you looked out over the Atlantic Ocean, you'll see a lot of clouds, little cumulus clouds, but still a lot of sun as well. Midwest, where the high pressure was now, lots of sunshine. And we can even look at different satellite images like this. If I go back one frame here, instead of looking at that one, I want to look at infrared. Infrared is basically looking at satellites that can tell the temperatures of what the height of the cloud is. So we see the colder clouds right here in this section and new colder clouds developing where that lightning was. Higher clouds with thunderstorms. We can see in the Midwest, there's low clouds basically, not very high at all. So this is an image that can be used all day long. Whereas the visible that we were looking at earlier, it's only good during the daytime. This is good the entire day through. And finally, I just wanted to give you a glimpse at another way of looking at things is here. This is a radar image. And you can actually see they've actually issued a severe thunderstorm warning for this cell down here. And there are several bright red thunderstorm cells here. Lots of yellow for heavier rain. So these are all methods. Remote sensing, meaning we're not looking or at the location, but we're able to detect what is happening further out. Now let's go in to discuss chapter 1 a little bit. So we're going to look at it here in the slideshow framework. So chapter 1 is monitoring the weather. We just looked at what the weather is. You saw a surface map, you saw a radar image and satellite. You put them all together, you saw how they changed over 21 hours. Well, so what are some of the characteristics of weather? Well, weather can have extreme things happen to you. In 1888, there was a monumental blizzard in the northeastern United States. There's been others since then, but it was one that actually clobbered New York City to the extent that it shut the whole city down at that time. It also was unforecasted. Nowadays, most blizzards are forecasted at least 2 to 4 days out. In January 2016, very big one in the United States and the eastern coast. So weather, what is it? It's a state of the atmosphere at exactly one moment in time. That's why when I say a weather forecast, I'm talking about in the future. If I'm just talking about the current weather, it's like you walked outside and what you felt right at this instant is what you have. Meteorology is just the study of the atmosphere, all the things that cause weather. Climate or climatology are both studies of what the average conditions are. In other words, we live at a certain location in the United States, for example. That location may get freezing weather starting in April, or maybe as late as May, or maybe that be the ending date of the freezing weather. These are important climate questions that scientists and people in the agricultural industry, when they're planting plants, want to understand. So that's climatology. All right. In order to understand that we want the weather exactly at this moment in time. So in other words, 7 a.m. in Eastern time is the same as 4 a.m. Pacific time. So if I am telling a person that lives in New York City to take a weather observation at 7 a.m., I also want a person that lives in San Diego, California to take a weather observation at 4 a.m. And that would be the picture of the weather over the United States, each one in the individual time zones. Here is just a map showing you the cold fronts and warm fronts like we talked about. The one thing I didn't mention was that around low pressure systems in the northern hemisphere, winds flow counterclockwise. Around high pressure systems, the air moves clockwise. And here you can see a better image of that as well. Along the front, interestingly, warm air, moist air, is lighter than cold air. So warm air is going to tend to rise up over cold air. And that means along a warm front, when it's moving north, the warm air is being pushed up over that cooler air to the north and covering a large area. Now, if you have a cold front, cold air is very dense, so it's very steep, the front, so it tends to not have as big of an area of precipitation with it. Remember this, fronts are three-dimensional. We're going to talk about a lot. The atmosphere is not just what's happening at the surface, it's what's happening at 5,000 feet up, 10,000 feet up, 50,000 feet up. So warm fronts bring a wide band of precipitation. When a warm front's approaching your area, many times you'll see some high clouds move in, then you'll see some lower clouds, and finally you'll get to the precipitation. That's a warm front. With a cold front moving in, you might get a very steep uh, thunderstorm, and then it's over. Very different kind of weather with them. And sometimes front comes past with no changes in the weather except a change in temperature or humidity. So if I want to describe the weather today, one of the things I would want to know would be what the maximum temperature is. If I'm looking at a certain time, it's maybe the temperature at that moment in time, or maximum temperature may be later in the day. Usually occurs in the early to mid afternoon. Well, the sun reaches its highest strength at noontime. So why would temperatures be higher later in the day? Well, the sun's still up. So that is why it continues heating. It starts heating when it first comes up in the morning and continues heating until it's setting in the evening. That's why max temperatures are later in the day, min temperatures right around sunrise. A dew point. Dew point is just a measure of moisture in the air. So if I went outside and could measure this, when there are means of measuring it, I would want to know what the dew point is so I could know how much moisture is in the air. If I have a temperature of 70 degrees and the dew point is 10 degrees, that is a very, very large spread of temperature there, very dry air. If, on the other hand, I had a temperature of 70 degrees and the dew point was 69, I may be having fog or precipitation. It's very moist air. Air pressure can rise or fall. We saw how it changed it dramatically just in 21 hours. Winds are just air in motion. Sky cover. When I look up in the sky, how much of the sky is covered with clouds? It showed you satellite imagery. We were looking at a geostationary satellite, which is parked literally right over the equator. We also have polar orbiting satellites. So they stay in the same orbit. The Earth actually rotates under them. And here I can show you a picture of the weather radar superimposed on satellite. Clouds. They're just ice crystals or water droplets. They're visible and they look different. Ice crystals look different than water droplets do. Water droplets tend to be darker. Ice crystals tend to be lighter. Fog literally is just clouds reaching the ground. There are various types of clouds too. Stratiform clouds. Stratiform clouds form in sheets. Literally, a large area of uniform clouds would be a stratiform cloud. They may bring rain. They may bring high clouds like cirrostratus clouds, but they're a large area where the air is ascending, causing a similar type of cloud. Cumulus clouds are puffy clouds. If you walk out in summer, you see these little puffy clouds in the sky, look like cotton balls. Well, they're the form of cumulus clouds. They can occur at any level in the atmosphere, and if they really get big and strong, they become cumulonimbus clouds. So when you're looking at the sky, sometimes it's interesting to see how cumulonimbus clouds form. Nimbo, it literally means rain. It can be a prefix. Nimbostratus is rain producing, or cumulonimbus would be a thunderstorm with cumulus clouds producing precipitation. And winds move, air moves in different directions in this atmosphere. In other words, if I am at the surface, I may have a south wind coming up from the south. Well, all we're saying is when we say south wind, we mean the air came from that direction. Maybe 10,000 feet up, on the other hand, I have a northwest wind. So I don't have the air moving in the same direction at different altitudes. It had to change as it was going up. And that is why stratiform clouds that form at different elevations move in different directions. You can literally sit there sometimes and stare at the sky, which I kind of like to do sometimes, and watch the clouds move in different ways. weather maps. I already showed you that. So I think that's about it for right now. This is this chapter 1. I want you to make sure you ask me any questions you have, and I hope you enjoy the course.